I started.
Okay. Welcome. Come on in, everybody. Grab a seat. Remember to look at the board. Those scientists. All right, so take a look at the board while everybody's getting seated. How are you today, Jenna? Did you have a good day?
Mostly.
Hungry for lunch, I bet.
Yeah, pretty hungry. It's also really hot outside.
It is very hot outside.
And there's no
They didn't make you
conditioning
go
in this
out
classroom.
for
No.
outside for stretching and stuff, did you?
No, we stayed in the gym.
Oh, okay, well, that's good. All right, everybody, let's get started. Okay, so up on the board, Jenna, can you read what it says, what the headline and the objectives say, please?
Let's be bird detectives. Objective.
Oh, and you might know, you not know because you're new to this school, but IWBAT means I will be able to.
Okay.
Yeah.
I will be able to use evidence from a hands-on investigation to explain how the shape of a bird's beak is suited to the type of food it eats.
Excellent. All right. And our do now that we have up there says we're going to look at the pictures of a hummingbird and a hawk. So you've been looking at that. What differences have you noticed between a hummingbird and a hawk?
The size.
The size for sure. Does anybody? Yeah. How big is a hummingbird usually?
I think like the size of like an adult's palm.
That's probably about right. Yeah. But depending on this, but yeah, hummingbirds are pretty big. Has anybody seen a hummingbird before in this class?
I have.
Oh, cool. All right. And how about a hawk? How big is a hawk usually?
A hawk's really big. Like probably the size of like a small poodle.
A small poodle? Yeah, probably. Yeah. And has anybody seen a hawk in Brooklyn?
Yeah, I saw one in Prospect Park once.
Yeah, me too.
It was really cool.
There's a hawk that I really like to watch. What do hawks eat usually?
I think they eat animals, like small animals, like mice and stuff.
Yeah, mice, birds. I even saw one attack a squirrel once.
Whoa.
And someone said that a friend of mine said that their dogs were outside, little Boston Terriers, and there was a hawk on the fence watching them to see if they were going to eat them.
Were they okay?
They were fine.
Okay, good.
But she brought them inside just in case. It looked like the hawk was thinking twice about it.
It'd probably be really heavy for them.
So besides the size, this is really, thank you, Jenna. Besides the size, what are some other differences we see about these two birds right here?
The beaks are really different.
Oh, how are they different?
The hummingbird's beak is really long and thin, and the hawk's beak is curved and looks kind of sharp.
That is a good observation. You're very right. Yeah, sharp. And given what we were talking about with the hawk, why do we think their beaks are different?
Probably because of what they eat.
What does a hummingbird eat? Does anybody know?
A hummingbird eats like plants, flowers.
Yeah. Specifically, and we're going to look at some other birds here. Specifically, a hummingbird goes up to flowers, but what do you think do they eat the whole flower, or do they...
They suck out the nectar.
The nectar. Who's heard that word before? Nectar? Does everybody know? We have some Spanish up here if anybody knows, but actually the Spanish for nectar is the same. It's nectar. But yeah, so a hummingbird goes up to flowers and sucks the nectar out. So why do we think a long beak would help with that?
Because the flowers are deep, so it would need the beak to go like deep enough in the flower to get the nectar.
Wow, that's an interesting theory. The rest of the class, what do you think? Up or down? Do you agree with Jenna? Most of you agree? Yeah. When we see a hummingbird, those of you who have seen a hummingbird before, how does a hummingbird drink? What is it doing? Does it sit on the edge of the flower?
It kind of hovers in the air, like its wings move really fast.
Yeah. Has anybody seen that before? It's really cool. A hummingbird just hovers in the air. So that beak probably helps it get into the flower while it's while it's hovering there in the air. How about a hawk? What do we just say a hawk ate?
Little animals,
Yeah.
rodents, and maybe small dogs.
Hopefully not small dogs, but yeah, who knows if it gets hungry enough. So when there's a hawk, how does the hawk eat, do you think?
It probably uses its beak to like peck at the. This is gross. To peck at the animals to like get inside to the meat.
Ew, yeah. Oh, does everybody think that sounds good? Yeah, peck. Yeah, so that's a very good point, Jenna. So yeah, you can imagine. Do you think a hawk could eat a whole? I mean, a hawk may be able to eat a small mouse, but what about a pigeon? Could a hawk just swallow a pigeon whole?
No, I think it would need to like eat it in parts. So it would have to use its beak to like cut into the pigeon.
Okay. So why doesn't it use a fork and a knife like normal people?
Because it doesn't have hands.
Ah, that might help, yes. Yeah. And it probably, yeah. And I can't get into IKEA to buy a set of forks and knives.
I mean, someone could let it into IKEA.
I suppose someone could let it into IKEA, but I don't know if it'll be able to reach its credit card. Great. Yeah, so that's a good point. So we have here four different birds. Besides the hawk and hummingbird, what other birds do you see here?
A finch and a duck.
Finch and a duck, yes. Or el pinzón, I apologize for my Spanish, and el pato, duck. What do you notice about their beaks?
The finch's beak is really small and short.
Small and
and
short.
not sharp.
That's interesting, yeah.
And the duck's beak is sort of like wide at the end, and I think it can open it large.
You can open it large? Yeah. I guess so, yeah. I've never really seen it. I guess when they quack. Has everybody seen a duck before at the park? There are those ducks there, too.
Mm-hmm.
Yeah. How about a finch? I've never seen... Actually, I knew someone who owned a finch that looked just like that. Finches come in a lot of different colors.
Yeah, I've never seen a finch like that in Brooklyn.
Yeah, I think that might be a tropical finch. Does anybody have a guess of what finches eat?
Bugs?
Maybe they ate bugs. If you've does anybody have a someone in their family that owns like a little bird, like a canary or something like that? Have you seen that in someone's house before?
No, but I've seen it at like a pet store.
And what at the pet store? What do they sell for those kind of birds?
Oh, seeds. That's right.
Yeah. So finches probably do eat little bugs, but I think their main food is seeds. And how about a duck? Does anybody have a guess of what a duck eats?
A duck eats something in the water, but I don't know what.
That makes sense. Yeah, they do eat something in the water. Who here has seen, when they see a duck in the water swimming, who has seen a duck suddenly put its head underwater and its little butt just wiggling up out of the water? Has anybody seen that before?
Yeah, I've seen that.
Yeah.
Oh, and people feed ducks bread, but bread doesn't actually exist in the water.
Bread probably doesn't exist in the water. Naturally, bread doesn't exist in the water. Yeah, if you see people giving bread to ducks, you're not really supposed to do that. It's not very good for them. I mean, humans eat a lot of stuff that is not good for us, but we don't want to pass on bad habits to animals in nature. So a duck, you may notice that when it's doing that, it's trying to find something underwater. Has anybody stepped into like a pond or a lake before?
Yeah.
Yeah. What does it feel like at the bottom?
Kind of like sandy and like gross. Maybe there's seaweed.
Gross. Yeah. Oh, that's interesting. Seaweed. Probably not seaweed in a lake.
Or lakeweed.
But yeah. I don't know if they call it lakeweed, but there are plants. There are plants under the surface of the water, and that's what ducks eat. And one thing that's interesting about a duck is that when it's eating that stuff, you imagine it's eating underwater, like that must be a different feel, right? To be eating stuff underwater, like to have all the water in there. Like
yeah, it would be soggy.
Like if you were eating a ham underwater, it would probably feel pretty weird. That's why they're able to get the stuff. They bring in a lot of water, but the water comes out the sides of the beak.
Oh.
So they have a special beak.
Is that why it's wide at the end?
That is one of the reasons. And so they can, because plants are small, and there's lots of them, they can get a lot of them together. So when we're talking about these beaks, we've talked a little bit about this before, but the beaks are, does anybody remember a phrase we use for the parts of the body that are just like, that are for a particular purpose on the outside?
No.
And we call them an external structure of the body. So structure, you remember we were talking about this before, a structure could mean anything. It could mean like a building is a structure, but it's a structure made for a certain purpose. And there are structures on the human or on animal and human bodies that have very particular purposes. And external, what does external mean? Does everybody remember?
Outside of the inside?
Outside of the inside. And what's the opposite of external?
Internal?
Internal, which is the inside of the outside. Oh, can you pause just a second? Thank you. Great. Okay, so we've been talking about beaks and their external structure. So let's, just for review, what does a hawk do with its beak?
It like tears apart the meat of the animals it catches.
That's great. And what about its beak makes it good for that?
That it has a curved end that's sharp.
Excellent. And a finch.
Finch.
Why do we think its beak is good for what it eats?
It eats seeds, and it's good for that because, like, seeds you don't really have to, like, chew or go too close. I mean, I don't know how you'd get seeds in nature without having to, like, dig somewhere. But seeds are little, so you don't have to, like, go, like, deep to get them or, you know.
Well, that's a good question. Where do you think seeds do come from in nature? Anybody? Like, if we talk about seeds from grass or seeds from vegetables?
The ground?
Yeah. Seeds, you may remember when we were talking about plants before, seeds are spread by various plants and are kind of everywhere. We don't always notice them because we're not looking for them, but they might be inside other things. They can crunch up. Now, what are some seeds that we eat?
Sesame seeds.
Sesame seeds.
Pumpkin.
Pumpkin seeds. Yeah, I've had pumpkin seeds before.
Poppy seeds.
Poppy seeds. Does anybody like a poppy seed bagel? That's my favorite.
Yeah.
Yeah. And sunflower seeds, if you've ever had sunflower seeds. Mm-hmm. When you eat sunflower seeds, have you ever noticed you have to, like, crunch into them?
Yeah.
Yeah. So you have to, like, not only pick up these things, but crunch them and get to the part that's good to eat. Great. And hummingbird, what did we decide hummingbird eats?
Nectar.
Yeah.
From flowers.
Mm-hmm. And why is its beak good for that?
Because it's long and thin, so it can get into the center of the flower to get to the nectar.
Excellent. You guys are doing a great job with this. And last of all, the duck.
The duck eats plants from the water.
Mm-hmm.
So it like dips underwater and puts its butt in the air so it can get to it.
Yeah. Great.
And water comes out the edge of its beak.
Great. All right. So here's what's going to happen now. So our big question, we're trying to figure out how the shape of a bird helps it survive. So we're going to test that question ourselves. We're going to go over to the lab. Everybody put on their imaginary goggles. I don't think there's anything of danger in this particular thing, but you never know.
But I want goggles.
All right. Put on your invisible goggles and your invisible lab coat. And what we're going to do, I've set up 4 stations, okay? Now, each one of these stations has a tool that models a real bird beak. Here, I'll take that from you. So each of these stations has a tool that models a real bird beak and a food that matches a real bird's diet. I have to add something to this. Just a moment. Almost forgot. Preparation. There we go. Okay. All right. So here's what's going to happen. What we're going to do is you're going to use the tool with each station. No, don't use your hands, just use the tool. And you're going to move as much food as you can into the stomach, which is this little plate here, okay? So that's what you're going to do. I should have had you get a timer. I was going to do it on my phone, but my phone is recording. So if you can use can you grab the timer on your phone? All right. All right. Thank you. I'll take that if you don't mind. Is it? If it will be okay. All right. So here's what we're gonna do. We're gonna do the timer. I'm gonna do 15 seconds. So for each of these, you're gonna do, in 15 seconds, you're gonna see how many of these things you can move to the stomach, okay? Mm-hmm. You ready for the first one?
Yeah.
Oh, wait a minute, sorry, I forgot an important thing. So you have a worksheet here, and you're going to, for each of these, you're gonna do 3 time trials, okay, to see how much you can get in. What we're gonna do is compare data to see if this is an effective tool, all right?
Okay.
All right. So trial number 1, we're going to start with, this is the tongs that we have here.
Can we eat the gummy worms after?
After we've done all the trials, you can eat the gummy worms, but only at the end.
Okay.
As with all the time in the laboratory, we never do anything, and especially put anything into our mouth, until we've gotten express permission to do so.
Okay.
Thank you for asking. All right. So, station number 1 is the tongs represent a hawk's beak, and the gummy worms represent pieces of little meat. Station number 2 has tweezers to be like a little finch's beak. They're a little long for a finch, but we're trying to get something smaller, and that's for getting the seeds. Station number 3, I'm trying something new here. They were saying to use a slotted spoon, but I noticed, this is, by the way, this has never been used, so it's less gross than you think it is, but this is a fly swatter, or what's called in Spanish, el matamoscas, fly killer. And we're going to use that to try to get up the rice that's here in the water. And then for station number 4, we have a straw, and we're going to use that to get the nectar into the stomach.
What is it really? What is it really, the nectar?
This nectar is really water with a little bit of raspberry syrup.
Does it taste like raspberry?
It does, yeah. I'd rather you didn't drink it until the end.
Okay.
Okay, because you can figure out what's the best way to do that as a hummingbird. All right, are you ready? So, all right, when I say go, we're going to start the first trial, okay? Mm-hmm. Right? Ready, set, oh, wait a minute, I did that wrong. Not minutes, seconds. All right, there we go. All right, so your mark, get set, go. All right, 13, 12, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Okay, so you started, I'll let you know, you started with 15 worms. So if you can write down your worksheet how many worms you got into the stomach.
I do it under trial 1.
Yeah, trial 1. Yeah. All right. Remember to always use units.
15 units?
No, I mean like seconds.
Yeah. Oh.
Seconds are a unit of time.
Right.
Great. All right, so we'll put the worms back in. All right. Let's see, cancel. All right, so wait, let's go back to the worms. We're gonna do 3 of them in a row.
Okay.
Okay? So we have data. All right, on your mark, get set, go. Oh, interesting. A change in technique this time. All right.
Should I have done one at a time, or is it? Okay?
What's that?
Should I have done one at a time?
Oh, you know what? I gave you the wrong information. I said seconds, and it's not seconds. I'm sorry. I don't know what I was thinking. It's 15 worms that we're doing, not 15 seconds. That is my fault. So you can cross out seconds. So if you're curious, you could write down that you got that done in 7 seconds this time. But what we're really doing is how many you've moved. Okay. All right?
Mm-hmm.
All right. Let's do one more.
Oh, what should I do for trial 2 that I just did?
This is trial 2. So you got 15 worms here and 15 worms here.
Okay.
Yeah. All right. All right. And the third trial.
Should I pick them up more one at a time, or is it okay to?
You can do it. Do whatever you're whatever bird you want to be. All right. Here we go. Go. All right. All right. Great job. All right. Now, by the way, so this is what makes this a little bit like a hawk, and what makes it not like a hawk, do you think?
It makes it like a hawk in that it's probably the size of the pieces.
Yeah.
But also, it wouldn't be gummy worms. It would be entrails.
Yeah, entrails. That's a good word. Has anybody heard the word entrails before? That means, what does that entrails mean?
It means it's insides. It's
Insides.
guts.
Ugh, gross.
Yeah, it's super gross.
Yeah, and we talked about something in the way that hawks work, which doesn't exactly work on this part of the lab. What's that?
That it has to tear into it, and also it probably couldn't pick up like 10 worms at a time.
Right. So we could, if you wanted to, you could see if you could tear a piece off this. But I don't think you have a very sharp. Well.
Probably entrails aren't.
Oh, you got there. You go.
Stretchy.
That's not bad. And what's the difference between these tongs and the tweezers here?
They're bigger, so
Yeah.
it's like wider, and also they
Yes.
can grab more.
Yes, I don't think a hawk usually has a mouth as big as these tongs, but this is a good way to test it. All right, so now we're going to go to station number 2. Everybody switch stations.
What should I put under average?
Well, what is the average of 15, 15, and 15?
15.
Yes. How do we know that?
Because the average is how many, like, of the 3, like the middle of them.
The middle of them?
Mm-hmm.
Yeah. Yes. How do we get the average?
I don't know. I'm really bad at math.
Oh, okay. Well, normally what we do with an average, this is first if you have all done this in math, an average is when you add all the numbers together and then you divide them by the number of numbers.
Mm-hmm.
So in the case, but we sort of know.
Do we get to use a calculator?
You could use a calculator, but I think the good thing is, why is it easy to do an average if the 3 numbers are the same?
Because it's just going to be the same as the numbers.
Exactly, that's right. Okay, great. Okay, so now we're going to try this one. Now we're going to try the Finch station, okay?
Mm-hmm.
All right. Are you ready?
Yep.
Ready, set, go.
Well, this is harder.
Yeah.
It's slippery. Okay.
This is your first day as a Finch, so it's...
Yeah, I was just born.
All right, time's up. Oops. Oh, no, what have I done?
I'll go to...
All right. Okay, great. How many did you get over?
4.
Okay, so you can write that on the sheet. All right, so let's try again. You're aging as a Finch, so maybe you'll get better at it. On mark, get set, go. Five, 4, 3, 2, 1. Okay. Excellent. All right, how many did you get this time?
8.
8. All right, well, I can add that in. And now you'll have a real average to do. All right, and one more. So on the mark, get set, go.
Yeah. I mean, darn.
4, 3, 2, 1, done. Okay. All right. How many this time?
7.
7. Okay.
I did worse that time.
So what are your 3 numbers there?
4, 8, and 7.
Okay. So what happens if you add them up?
12 plus 7, 19.
19. Okay.
Mm-hmm.
And then what's the closest number to an average for 3 going into 19? 3 times what is close to 19?
5 is 15. 3 times... No, wait. 3 times 5. 6? 3 times 6?
3 times 6 is 18. Yeah, so that's pretty close. So you could say it's about 6. Is about your average, which is maybe what you might have guessed if you were doing 4 and 8 and 7. All right, great. Well, later on you can use your calculators on the worksheet. All right, great. All right, now this one could be tricky. I gave you a special bowl to try to see if the fly swatter, the mata moscas, will work. So, all right, on your mark, get set, go. Oh.
Oh, this sticks to the fly swatter.
Okay, well. Oh. We'll say the hand is fine for this part of it. All right. All right, great. All right, now it might be a little hard to count all these because I didn't want to do only 15 grains of rice.
Yeah.
But what a percentage do you think you got of the rice? If you were to estimate.
I'd say like
I got that much in there.
maybe 70%.
Yeah, it might even be more. Yeah, so you could say that maybe 70. Yeah,
75.
So we'll go with your estimate. Put 70%. All right. We'll do that. Do that 2 more times.
Yeah.
This one's a little messier.
I don't think I can get them all on.
Okay. You can use your hands if you want.
Oh.
Like every lab, we have Kleenex right here if you need it. Okay.
Mm-hmm.
All right. Let's try it again. Your mark, get set, go. We'll assume that your hand, when it's getting off the fly swatter, that's your tongue, so you're allowed to use that.
Okay. Ducks have tongues?
I assume so. You know what? Like many things. Oh, time's up. Like many things, it'll be something that I look forward to looking up. I assume they have tongues. Okay, so what do we think now? Maybe even more this time, right?
80% maybe?
Yeah, let's say 80%. Okay, so you're writing down 80. We'll do one more. Licking the rice.
Should I
Licking the
actually-
aquatic plants off. No, don't actually do that. But that's your hand tongue, so.
Yes.
All right, great. All right, last time for the duck.
Mm-hmm.
Here we go. Go. Oh.
I don't even need my hand tongue.
All right. What do we think that time? Stop. What do we think we got that time? That might even be more.
85?
Yeah, let's say 85. Okay, we'll have you do the averages later on that. And then, last one, let's do the hummingbird. Do you have a strategy for this?
I think I'm gonna suck, but try not to suck it all the way.
This should be interesting. Okay, great. This is about a quarter. We can maybe do percentages again. It might be hard to do percentages with this. Let's say if we were doing this more thoroughly, we would measure the liquid every time. But in this case, let's just see how you do.
Mm-hmm.
All right, 15 seconds. Go. All right. Are you getting it fully in your mouth?
Mm-hmm. Uh-oh.
All right. How'd that go?
Well, I drank some of it. God, I don't know, like 15%?
Yeah.
Sound right?
Maybe. Yep. Here, I'm going to try something different. I'm going to pause just a second. Okay, so we're refining our experiment by, this is a little more flour-like. All right. How can you do it without your mouth? Do you have any ideas?
I mean, I could pour it, but that wouldn't be using the tool.
Test one using the tool, a different way to do it. Can you think of a way to do it?
I guess, no. I mean, I could do it, I could like do this, but I think that would be really slow.
Yeah, try that way.
Okay.
How do you do it? Yeah. Yeah. Well, whichever you think. All right, you ready?
Yeah.
All right, go. In a lab, we definitely have to give everybody their own plastic straw. We're being... Okay, so let's assume you just did 3 of those. All right, how much do you think you got?
Like 30%?
I guess we could test it by pouring it back in and eyeing it.
Oh, yeah.
Yeah, maybe about 30%. All right, great. And just for the yeah, you can.
What did I do the first time? It was.
We'll pretend you got that all right.
Okay.
This is taking a little long. All right, so the last thing we're gonna do, I want each of you to try using the tools on different parts. Like try using a different beak for a different thing, and this is, we won't write data down for this, but this is just a kind of to sort of test, because in science it's sometimes nice to test what works and what doesn't work.
Okay.
So try the different tools on try the different tools on the meat, the gummy worms. You've already tried that.
Yeah.
Try the different ones. All right. That works pretty good.
You can only do one at a time, though.
Yeah, and if that were like the size of the mouth,
Yeah.
it'd be a little hard for the finch. What about the duck's mouth on the? Oh wait, you're doing the hawk.
Oh, sorry.
Yeah,
the
yeah.
duck's mouth.
Yeah, on the gummy worms. Okay, duck's
The bowl's
mouth is
too
not very
small.
good at the seeds. Can the duck deal with the worms? Not having a great time with that. It's possible.
I mean, if I used my tongue hand, but
Yeah.
that doesn't seem.
Yes.
There we go.
Okay. What about? I mean, you probably don't even need to test this, but we're assuming the duck beak is not going to be very good with the.
No, I mean.
Yeah. All right, great. How about the trying the hawk and the finch across these different things? Yeah. Well, it's pretty good at the seeds.
It doesn't hold as well as the tweezers,
No.
though.
How's the hawk do with aquatic plants? It's slow.
What kind of plants would be this size?
Well, so there is actually there's something called duckweed. There were lots of they're like little green leaves. They're like tiny little leaves, and they just eat a whole bunch of them. But there's different kinds of plants that they eat. And then how about the finch? What does the finch do on the? Not so great. That would take a finch would
Yeah, that would take a while.
drown trying to use it. And
Also, I don't
then-
think finches could float.
Yeah. And then how about either of those with the water? Yeah, not ideal. I mean, it's not a perfect experiment because of course birds do drink water, but they don't really drink it by picking it up with their beaks. Okay, great. All right, so the last part of this is so you have your data sheet. You wrote down your pieces. We'll assume you did your averages already. So the last part is so I just like what I want you to do is take a look at your data sheet and see which tool collected the food, the most food, or the most efficiently. And then we'll talk about that. And then afterward, and then think about that. But also, I want you to use claim evidence reasoning, or CER, the way we were talking about. So it's your turn to be a scientist. I want you to pick one of these tools, and I want you to make a claim about which food it's best adapted to collect. So you use your data, and then you see at the bottom of your worksheet, you have like a little sentence that I want you to fill out so that you so you're making a claim based on the evidence in your data of why that shape does well. Okay, so I'm going to put you on pause. All right, so let's hear what everybody has to say. Who wants to share their claim and their evidence and reasoning about the beaks? Anyone? Yes, Jenna. Would you like to share with the class?
I claim that the tongs works best for the worms. My evidence is I got all of the worms and none of the other tools got all of the food. Mm-hmm. This shows that the hawk's beak is most efficient for eating its food.
Oh, great. Excellent. Does everybody agree with that? Andy, do you agree with that?
He hasn't been raising his hand.
You need to participate more in class, Andy, but we'll talk about that later. Yeah, that's great. Well, I hope you all learned something today. So today we discovered that a bird's beak isn't random. It's an adaptation that helps the bird survive by getting the exact foods it needs. So next time you see a bird outside, take a look at its beak and see if you can guess what it eats. All right? Everybody good?
Can I eat the worms now?
Everybody, you can eat the worms. Go ahead.
Oh, they're sour.